Good evening to all of you. Now, this is my second video regarding our Penetrant Testing Fundamentals classes. Now, I will just give you a quick recap of my first video. In the first video, we have discussed about the what are the issues to address, the introductions. We have discussed about the apparent width of the crack indications. How does it increase by the applications of a penetrant? Second things, what is the meaning of dry penetrant? Dye is the coloring agent or is the powder, and penetrant is the liquid carrier. Third is the indications from different process. It is the visible dye penetrant and this is the fluorescent penetrant. Now, what are the limitations? What can be inspected via PT and what cannot be inspected via PT? And what are the typical defects that can be inspected via PT? Now, today we will be exclusively discussing about principles of penetrant testings. What is the principle of penetrant testings? Now, the main principles of penetrant testings I have highlighted with red letters. The first principle of penetrant testing says that in the penetrant testing, a liquid with high surface wetting characteristics. What is the meaning of high surface wetting characteristics? I will discuss in the next slides. Second principle that we need to remember is the capillary action. Now, what is capillary action and how does it takes place? How does it takes its own place in penetrant testings? That we will also discuss in the next slides. Second thing is that this is the blotting action. What is the meaning of blotting actions? Blotting means to take the penetrant out, which is put inside the defect or which is hidden inside the defect. Then the last principle is the contrasting background provided by the developers and the visual indications. So these are the four major physical principles of penetrant testing that you need to remember. First is the high surface wetting characteristics. What is that we will discuss, and what's its role, and what is the role of high surface wetting characteristics in the penetrant testing we will discuss. Second thing, the capillary actions. We need to know about the capillary actions and or some fundamental about capillary actions and how does it affect the penetrant testing process. Third thing is the blotting action. The blotter, the developer acts like a blotter, and what's the blotting action? And the last thing is that the developer provides a contrasting background and the visual indications. So these four principles you need to remember and you need to understand for the principle of penetrant testing. Our basic process of PT. First is clean and dry the component. Now you remember I have already told you that pre-cleaning is the most important part of any penetrant testings. Without effective pre-cleaning, you will not find or the effectiveness of penetrant testings will be very less, because either you will be missing a defect that is countable or you will be getting some irrelevant indications or some false indications, or your acceptance or your acceptance of indications or your final indications during your acceptance stage may go wrong. So first is pre-cleaning the documents, and for aerospace components or any other components, clean and dry the component is the first step. Now, what is the meaning of clean and dry the component? Cleaning, what are the process of pre-cleaning? This clean and dry the components is the step for pre-cleaning. Now, what are the steps in pre-cleaning and what you will be using in pre-cleaning, that we will be discussing in the next slides. So, first is clean and dry the components, and you have to dry. Why you need drying? Because you see, when the material is subjected in servicing conditions or for aerospace components or any other components that is subjected to high stress, high temperature, high corrosion conditions, in that cases you need to dry the component to evaporate the volatile impurities, or the, you can say some grease, some gaseous contaminations. So these things will get evaporate or will get dry out during the drying process. So you have to clean the part, then you have to dry. First clean and dry. Then second thing is that after cleaning and drying, you need to apply the penetrant. Now what is the time for cleaning and what is the time of drying, and after how much drying time is required for a part, that we will discuss. So first step is clean and dry the component. This is the most important steps, that is pre-cleaning. Second is apply the penetrant. You need to apply the penetrant. Third, remove the excess penetrant. Now see, this is the excess penetrant. This is the surface of the part. Now this is the excess penetrant. This is the excess penetrant. You can see this green layer above, from this point to this point, is the excess penetrant. Now when you remove the excess penetrant, this layer will be vanished. This layer will be vanished. And you need to remember the small things. See, a small amount of penetrant also get evacuated from the bottom portion of the defect. You see, this much amount of penetrant will also get cleaned up due to the pressuring force of cleaning, pressuring force of water, if in case of water washable penetrant. You see, this much amount of void will create on the bottommost part of the defect due to the pressuring, due to the washing force, or the pressure created by the washing force of the cleaning liquid during the removal of excess penetrant. You see, this is the excess penetrant. Now this much amount of layer is vacant here. Then apply the developer. You need to apply the developer. This slight blue color calls for the developer. Now how you would, what kind of developer you will apply? What is the right process to apply the developer? What is the required time you need to apply the developer after the removal of excess penetrant? And what is the developing time, that we will discuss the next slide. And it depends upon the type of penetrant materials you are using. The last is visual inspection. And remember, this visual inspection is very simple, but you just see in the previous 2-3 figures. Now this is the penetrant that got void, or you can see there is a void created over here. Second is also a void created over here due to the washing of excess penetrant. Now you see this void is now getting much more larger, because due to the blotting action of the developer imparted upon the penetrant, and this much of penetrant that will be blotted by the developer, and this amount of penetrant will go above the crack surface for the indications. When you spread the dye, when the blotting actions will happen, some penetrant from this part of the defect will go upwards due to the reverse capillary action. Now it is remembered that the capillary action, which is it has to be remembered that the capillary action which is responsible for the entrapment of the penetrant inside the defect, the same capillary action is also responsible for the blotting out of the penetrant. You see, there is a void created over here, and this much amount of penetrant is now spread outside, or you can say due to spreading of outside, due to the spreading of penetrant, due to the blotting action of developer, you are getting a void over here, and it will give the indication. And now this is the apparent width of the indications, and now you see this is the indication glowing, the glowingness of the indications. Now the indications glowingness depends upon your visible penetrant and your fluorescence type of the penetrant. Now for visual inspection, when you are using visible type of penetrant, you will have to use your naked eye, or you have to see under white light. But when you are using fluorescence penetrant, you have to see the part under ultraviolet. Ultraviolet lightning is required, and you need a dark room. Now, what is the conditions of dark room? What is the minimum intensity of the UV light that should be on the part, that we will discuss, and that is mentioned in the specific standards that you will be using in the company will be working. So these are the basic process of PT. Clean and dry the component. This is the most fundamental and most important part. If this step is not done clearly by any penetrant testing operator, all this operation will go in vain. So clean and dry the component, apply the penetrant, remove the excess, apply the developer, visual inspection, and last is post clean the component. Now post cleaning is also very important. Pre-cleaning is important and post-cleaning is important, because if you are not doing the post-cleaning religiously, or you are not doing the post-cleaning of the component in a very very thoroughly manner, or you are not doing, or you are not following an effective post-cleaning method, then the residues of the penetrant material that will remain inside the material due to ineffective post-cleaning may cause, and certainly cause, problem in the further functionality of the part, or in the further role of the role of the part in its in the part's next assignment. Because these residues, when you will talk about especially for aerospace components, this residues of penetrant material, when comes in contact with some corrosive atmosphere or come with contact with some other materials, they will create some other chemicals that will be harmful to the parent material. So post cleaning of the part is also very important. Now pre cleaning, apply penetrant, remove excess, apply developer, visual inspection, post cleaning. These are the 6 basic steps involved in any kind of penetrant testing, be it visible, be it the fluorescent particle testings, and which type of penetrant you are using, or what kind of developer you are using. These 6 basic steps you need to remember, and you just need to remember the concept that how the blotting action happens due to this void created in this bottom part of the defect, due to this blotting of this penetrant, or due to the sucking of the penetrant by the developer layer that is present inside the above the cloth. Now what makes PT work? Now here we need to know about the physical principles of surface tension. Now what is surface tension, and how it affects penetrant testings, that we will now discuss. You see, surface tension is nothing like that. It's something like this. When you make a balloon, by giving air inside that balloon will make a shape like in a rounded manner, in a circular manner. And if you press any part of the balloon, you will feel some kind of elastic forces. When you just press that rubber of the balloon, you will find, or you will feel that elastic forces acting on the surface of the balloon. That is the surface tension. That is called the surface tension. If you want to understand it, and if you want to understand it very clearly, the surface tension is the tension that remains on the surface. In the case of a balloon, it is due to the internal pressure of air. Similarly, that kind of action happens in case of liquid also. Now you see these 3 droplets, 1, 2, 3. Now you can see, now here the surface tension tends to move, or tends to shape the water particle into a circular manner, into a circular shape. Here surface tension acts it's not that high in that case, and here it is very less. So the first thing is that the surface tension means the tension acts on the surface of the liquid. Here we takes about the surface tension of the fluid or the liquid. It is an elastic force. Now I already have told you that stretch membrane of the balloon, that this elastic nature of that rubber of the balloon is equivalent to the elastic force that acts tangential to the fluid surface due to reduced area. It's called surface tension. Reduction in here in case of a fluid surface, when it tends to take the shape of a circular shape, each and every point of the fluid is stretched. It behaves like a stretched elastic membrane, just like the rubber of a air-filled balloon. That is called surface tension. Now, what is tension? Tension is equal to, you can say, the force into distance, and the tension for a droplet of liquid is half of P naught minus Pi into R, where P naught and Pi is the difference of internal and external pressure, and R is the radius of the curvature. If you are, I just gave you the example of a bubble. Similarly, in case of a liquid, if this is the internal pressure acts in this direction, internal pressure acts in these directions, and external pressure acts in these directions, and the difference of these two pressure multiplied by the radius, you will give you the net amount of surface tension that acts in the tangential direction to any fluid surface. Now, A, B, C are three types of droplets acted upon by different surface tension. Now, the surface tension at interference of two medium is can be expressed by gamma Lg. This things it's a bit